Imagine a world where our most stubborn waste is no longer destined to choke landfills for centuries, but instead is devoured by a living organism, a humble fungus evolved to feast on plastic. It's an idea that sounds almost magical, the kind of solution that could flip the script on our global pollution crisis overnight. But as with many things that seem too good to be true, the reality is a lot more complicated. Let's start with the fungus itself. In the dense, teeming heart of the Amazon rainforest, researchers from Yale University stumbled upon a species with an astonishing appetite, Pestaloteuopsis microspora. This fungus doesn't just survive in the harsh jungle. It thrives on what most living things can't even recognize as food: polyurethane. Polyurethane is one of the most common plastics on Earth, used in everything from shoe soles to insulation to car parts. It's valued for its durability and flexibility, but those same traits make it a nightmare for the environment. Left alone, it can persist for hundreds, even thousands, of years. Pestaloteuopsis microspora, though, has a secret weapon. It produces specialized enzymes, biological scissors, that snip apart the stubborn chains of molecules that make up polyurethane. These chains, called polymers, are what give plastic its strength and longevity. The fungus breaks them down into simpler compounds, which it can absorb and use for energy. Even more remarkable, it can do this in the absence of oxygen, a key advantage since landfills are often oxygen-starved places where most decomposition grinds to a halt. Inspired by this discovery, let's run a thought experiment. What if we took this fungus, our would-be plastic savior, and introduced it into a landfill teeming with polyurethane waste? In our scenario, we carefully shred the plastic to give the fungus more surface area to work on. Then, we unleash our microbial champion. At first, it seems like a miracle. The fungus gets to work, multiplying, spreading, and breaking down the plastic into smaller and smaller pieces. The landfill, once a monument to our throwaway culture, starts to shrink as the plastic disappears. But as with all simple stories, the reality has layers. As the fungus digests the plastic, it produces byproducts, chemical leftovers from its unusual meal. And in the oxygen-poor environment of a landfill, those byproducts become a feast for a different group of microbes, archaea. These ancient organisms thrive without oxygen, and as they gobble up the fungus's leftovers, they release methane as a waste product. Methane is a greenhouse gas with a global warming potential about 80 times higher than carbon dioxide over a 2-decade period. In other words, our fungal solution to plastic pollution is also a recipe for accelerating the climate crisis. Instead of solving one environmental problem, we risk making another even worse. Then there's the sheer scale of the challenge. Humanity produces over 400 million metric tons of plastic every year, a number that's expected to nearly triple by 2050 if we stay on our current course. The idea of deploying enough fungus to eat through even a fraction of that is almost mind-boggling. Transporting, cultivating, and controlling vast quantities of a living organism on a global scale isn't just a logistical challenge, it's a potential ecological disaster waiting to happen. Because this fungus isn't native to most of the world, introducing it into new environments could have unpredictable effects. It might outcompete local fungi that are essential for healthy soil and forests, or disrupt delicate ecological balances in ways we can't foresee. And then there's the question of containment. How do we make sure the fungus only eats the plastic we want it to, and not other materials? What if it evolves or swaps genes with local species to become even more voracious? The more we look at the problem, the clearer it becomes. The miracle fungus isn't a magic bullet. At best, it's a specialized tool, one that could be used in carefully controlled industrial settings to deal with specific types of waste. But unleashing it on the world's landfills won't solve the core problem, because the plastic keeps coming. And that brings us to the real heart of the issue. The plastic already in our landfills is just the visible tip of a much bigger iceberg. Our relentless, ever-increasing production of new plastic. In the last 20 years, global plastic production has more than doubled, driven by the ease and low cost of making new plastic from fossil fuels. It's often cheaper to manufacture new plastic than it is to collect, clean, and recycle old plastic, a perverse economic incentive that keeps the plastic floodgates wide open. Recycling, despite decades of public campaigns and blue bins, has barely made a dent. Only about 9% of all plastic ever made has actually been recycled. The rest ends up in landfills, incinerators, or scattered across the environment, from ocean gyres to the deepest mountain valleys. Worse, about half of the plastic we produce each year is for single-use products, items designed to be used for minutes and discarded, but destined to persist for generations. This is no accident. As the world moves away from fossil fuels for energy, the petrochemical industry has found a new lifeline in plastics, embedding oil and gas into every corner of our daily lives. That shift starts with us. Each time we choose a reusable bag, a refillable bottle, or a product with less packaging, we nudge the system in the right direction. But personal choices alone aren't enough. We need systemic change, from the boardroom to the halls of government. Right now, the United Nations is hammering out a global plastics treaty, an agreement that could, for the first time, put real limits on plastic production and force companies to take responsibility for their products from cradle to grave. Supporting these efforts, and the organizations pushing for ambitious change, is one of the most powerful things any of us can do. In the end, the story of the miracle fungus is a lesson in humility. Nature can provide us with astonishing tools, but it can't save us from our own excess. The true monster isn't the plastic itself, but the system that produces and discards it without a second thought. To build a future free of plastic pollution, we don't need to unleash a mutant fungus. We need to unleash our collective will to change. That's how we turn the tide, not with a single miracle, but with millions of everyday choices and the courage to demand something better. The real solution isn't waiting in a petri dish. It's waiting in our hands.